In this presentation, I want to talk to you about surveying systems. Metes and bounds is a system of land description that identifies a property by describing the shape and boundary dimensions of a unit of land based on its edge distances and bearing angles from a defined starting point. When the United States was colonized, land was described using the accepted English system of metes and bounds. Metes and bounds descriptions consist of a closed loop of distances and angles that describe the property boundaries. However, early metes and bounds descriptions often included non-permanent landmarks such as trees, streams, and rocks. This practice resulted in frequent property disputes. A mete is the boundary described by a distance and direction between property corners. An example would be north 30 degrees west at a distance of 567 feet. A bound is the property that is described less accurately. An example would be along the stone wall at the edge of Isaac Dunn's property. The point of beginning is a property corner from which the description originates. Think of it as the starting point. Lines are described with respect to natural or artificial monuments and baselines. Line length is measured along a level plane. Directions are described using bearing angles with respect to the previous line. This is a partial example of a metes and bounds description. From the point of beginning, proceed north 67 degrees 35 minutes east along said right-of-way line of State Road Number 1, a distance of 120 feet. Early metes and bounds surveys were commonly performed using a gunner's chain, shown in the image. One chain equaled 100 links, or 4 rods, or 66 feet. There were 80 chains in 1 mile. Today, links are typically given in decimal feet. An example would be 315.75 feet and not 315 feet 9 inches. A bearing is the deviation from a known line or direction, measured in degrees, minutes, and seconds. Here are a few examples. North 25 degrees 35 minutes and 12 seconds east. South 22 degrees 35 minutes west. Angles are generally measured in degrees, minutes, and seconds. 1 degree equals 60 minutes, and 1 minute equals 60 seconds. From the initial point of the property line, determine the direction indicated by the first letter in the bearing designation. In this case, N means north. Then turn the indicated angle toward the direction indicated by the last letter, east, which is counterclockwise when viewed from above. In this case, S means south, so begin by facing south. Then turn 22 degrees and 35 minutes toward the west, which is clockwise when viewed from above. We will now lay out some property lines. Starting from the point of beginning, lay out the direction of the property line using the bearing. Measure and mark the length of the line from the point of beginning along the bearing line. The end of this property line then becomes the initial point of the next property line. Starting from the end of the previous line, lay out the direction of the next property line using the bearing. Measure and mark the length of the line from the point of beginning along the bearing line. The end of this property line then becomes the initial point of the next property line. And so it continues until the final property lines return to the point of beginning. In many cases, the distances and bearings in the legal description will not return exactly to the point of beginning. In early descriptions, the error can be quite large. As you can imagine, slight errors in a distance or bearing can result in overlapping property descriptions. In addition, many early metes and bounds descriptions were based on non-permanent landmarks such as trees, streams, and rocks. This procedure resulted in frequent property disputes. Thomas Jefferson suggested a more uniform and orderly method for the division and sale of government-owned land. The new system has come to be called the rectangular survey system. The rectangular survey system is based on a series of north-south lines referred to as principal meridians. Each principal meridian has a corresponding east-west baseline. This map shows the location of the principal meridians and baselines in the United States. This close-up map shows principal meridians and baselines in the Northwest. Originating from each intersection of a principal meridian and its baseline, the land is divided into small areas with range lines which run north-south and are spaced 6 miles apart. Township lines run east-west and are also spaced at 6 miles. The resulting 6-mile by 6-mile squares are called townships. The location of a township is indicated using coordinates that originate at the intersection of the baseline and the principal meridian. For instance, the township designated as Township 1 North, Range 1 West is in the first row township to the north of the baseline and the first column of townships west of the principal meridian. The township designated as Township 1 South, Range 2 East is located by counting 1 township to the south of the baseline and 2 townships to the east of the principal meridian. Each township is further divided into 36 sections. The sections are always numbered beginning with Section 1 in the northeast corner and counting to the west, and then following a serpentine pattern to end with Section 36 in the southeast corner of each township. Remember that each township is 6 miles by 6 miles. Therefore, each section is 1 mile square. Each section can then be divided into even smaller parcels by referring to quarters or halves of the section. 1 square mile is equal to 640 acres, so half a section contains half of 640 acres, which would be 320 acres. A quarter section contains 1/4 of 640 acres, which would be 160 acres. These partial sections can be further divided into smaller and smaller subdivisions such as quarter sections or half-quarter sections. The partial sections are identified by their location within the section. For example, the southeast quarter of the northwest quarter can be found by identifying the northwest quarter of the section and then identifying the southeast quarter of that quarter. This is a satellite image of Kansas farmland showing the land divided into square parcels. Each smaller square is a quarter section. Each larger square is a section. The circles are a result of central pivot irrigation in which water is fed from a well in the center of each field and is dispersed through a long pipe that rotates on wheels. The color of the crop circle depends on the type of plant. Do you think the designers of the irrigation system consider the size of a section and quarter section when sizing the system? Let's look at this rectangular survey example. Township 1 South, Range 1 East, 3rd PM, Section 25, south half of the northwest quarter. The 3rd PM is the 3rd principal meridian. Knowing that, can you look at this map and determine in what state this property is located? Can you find Township 1 South, Range 1 East? Find Section 25. Remember, each township is divided into 36 sections, numbered as shown. Section 25 is toward the lower right-hand corner of the township. To locate the subdivision of the section, start from the last division listed in the description, which would be the northwest quarter. Divide the section into quarters. and look at the northwest quarter, which is located in the upper right-hand corner. Divide the northwest quarter into halves horizontally. The description is the south half of this quarter. Eventually, it became necessary to devise a system of land description that was not restricted to the rectangular parcels that resulted from the rectangular system. The lot and block system provides for the subdivision of a tract of land into many individual lots of various shapes and sizes. The lot and block system inspired the term we hear quite often today called subdivision. The legal description of the lot is recorded as lot number and block number of the named subdivision. The lot and block system is used with metes and bounds and rectangular survey descriptions. This partial plat shows the use of a lot and block system in a neighborhood located in Charleston, South Carolina.